This is pre-AP, pre-calculus. Notes 9.5, solving trig equations. Consider the trig equation secant of theta is 2 square roots of 3 over 3. The plan outlined below is the process you will perform when solving trig equations of this form. We're looking for two values of theta, so that theta is between 0 and 360 degrees without a calculator. If it says without a calculator, then that means the ratio you're given is from the unit circle. That means that theta is it's an angle that makes a special right triangle or a quadrantal angle. First piece of advice, write the equation in terms of sine, cosine, or tangent. Well, this is currently in secant. Secant is reciprocal of cosine. Cosine of theta is 3 over 2 square roots of 3. Now, this does not look familiar from the unit circle. If we rationalize our denominator by multiplying by 1 in the form of square root of 3 over square root of 3, we're going to get 3 square roots of 3 over 2 times 3. The 3's cancel. We end up with square root of 3 over 2. You should recognize that fraction. Let's come back to that in a moment. Number 2, make a note of the two possible quadrants of termination for theta based upon the sine of theta. Well, cosine of theta is equal to x in the unit circle, and this is currently square root of 3 over 2, which is bigger than 0. Our conclusion, if x is positive, then theta terminates to the right of the y-axis. Part 3, take the inverse trig ratio of both sides of the equation to find the angle that satisfies the equation. Since you're doing it without a calculator, the angle should be an angle on the unit circle. So in other words, we have cosine of theta is square root of 3 over 2. We're trying to figure out what theta is. If we do cosine inverse to both sides, we get theta is cosine inverse of square root of 3 over 2. We are trying to figure out what theta is. Don't know what it is yet. Let's go to step 4 and we'll come back to that. Draw the angle found in step 3 in standard position. This angle should terminate in one of the two quadrants mentioned in step 2. Well, I don't think we can do that until we can figure out what the square root of 3 over 2 is. We concluded that theta is right of the y-axis, and since cosine isn't 1, it's going to be in quadrants 1 or 4. So let me draw. This is going to terminate in quadrants 1 or 4. And we know that the x value, if we make a triangle, let's just draw these triangles. This x value has to be square root of 3 over 2. Which of the special right triangles has square root of 3 over 2 in it? One that also has a half and a 1. What does that make the reference angle? In each case, it makes the reference angle 30 degrees. See how that works? If the reference angle is 30 degrees, then the angle we're trying to find is 30 degrees, or 330 degrees. So the answer to the question is 30 degrees and 330 degrees. What we should know from the very first step, right here, is that square root of 3 over 2 is in a 30, 60, 90. And since cosine of theta is square root of 3 over 2, that makes the adjacent leg, x, squared root of 3 over 2. So that makes the reference angle 30 degrees. Part 2 tells us what quadrants we're in. We're in quadrants 1 and 4. So if the reference angle is 30 in quadrant 1 and 4, the angles we're trying to find is 30 degrees or 330. Let's try another. Use the plan described above to solve this equation. Sine of theta is negative square root of 3 over 2. Well, let's figure out what the quadrant it's in. Step 1 was put it in terms of sine, cosine, or tangent. It's already in terms of sine. So we're on step 2, figure out the quadrant. This is negative square root of 3 over 2, which sine is y over r, which, you know what, I'm just going to say it's y. Let's assume unit circle here. That makes y less than 0. The conclusion is that theta terminates below the x-axis. Because y is negative. So that means that our reference triangles that we're going to draw to be below the y-axis has to be here and here. And the y value is negative square root of 3 over 2 in both cases. What special right triangle has square root of 3 over 2 in it? The one that also has a half and 1. Opposite the large leg is the bigger angle of 60 degrees. So the reference angle is 60 degrees. Theta, which is sine inverse of negative square root of 3 over 2, we are saying that that is going to be 180 plus 60, which is 240 degrees, and 60 degrees short of 360, which is 300 degrees. Let's try another. This is interesting. Solve each of the following trig equations, finding two values between 0 and 360. Give your answers to the nearest 1,000th of a degree. Show your work, including your graphical analysis. Well, this is going to require a calculator because this is a ratio that we do not recognize from the unit circle. So this is a calculator problem. Well, let's first figure out, first of all, is it in terms of sine, cosine, or tangent? Check. Second of all, do we know what quadrant it's in? Sine of theta is 0.735, which is equal to y, which is greater than 0. Therefore, theta terminates above x-axis. So we want to know what theta is. It's sine inverse of 0.735. To get a reference triangle above the x-axis, we got to be in quadrant 1 or in quadrant 3. If you put into your calculator sine inverse of 0.735, you're going to get that theta, keep in mind, is 47.307. That's this angle right here in standard position. So that's one of the angles that's in degrees. The other one is going to have the same reference angle. I need to make this a little bigger, of 47.307, which means the angle in standard position is 180 minus that. And my organization of my work here is very poor. If I subtract 180 from that, it should be 180 minus that, so my signs are backwards here. That's going to make that 132.693 degrees. Let's try another one. Cosine of theta is negative. So what quadrant's that going to be in? Well, if cosine of theta is negative 0.482, and that's equal to x, and that's less than 0, the conclusion is that theta terminates left of y-axis. So when we draw a picture for this, our reference triangle is going to be in quadrants 2 and 3. And we know that the x value here is negative 0.482. Theta is going to be cosine inverse of negative 0.482. Put that in your calculator, you're going to get 118.816 degrees. Now that's going to be this one here. What does that make the reference angle? That's going to make this reference angle 61.184, which means this reference angle is 61.184. So this angle here is going to be 180 plus 61.184, which is 241.184 degrees. Number 3. The advice that was given is put this in terms of sine, cosine, or tangent. So this would be sine of theta is the reciprocal of this fella. Sine is y, and that's less than 0. Therefore, theta terminates below the x-axis. So when we figure out what theta is, it's going to be cosecant inverse. I'll tell you what, let's use sine. It's going to be sine inverse of this monster. We're going to get 2 answers every time we do this. So we know it's below the x-axis. It's going to be in quadrants 3 and 4. You put sine inverse of this into your calculator, you're going to get negative 54.068. And I can't write that as my answer because the direction said the angle has to be between 0 and 360. So not the answer, but that tells us that this angle right here, the reference angle is 54.068. This one's also 54.068. So we don't have to actually make these into triangles. If it's easier to show, we can just put the terminal side, whatever works best for your brain. So this angle is going to be 180 degrees plus 54 degrees. That's going to be 234.068 degrees. And this one here is just about 54 degrees short of 360. It's going to be about 305.068 degrees. Check out number 4. Tangent of theta is this fella. Tangent's y over x. This is less than 0. Our conclusion is that theta terminates in a quadrant in which x and y are opposite signs, which would be quadrants 2 or 4. Theta is going to be tangent inverse of negative 8.92. You get 2 answers for this. You put that in your calculator, you're going to get that this is negative 41.733 degrees, which is not one of our answers because the direction says we need an angle that is between 0 and 360. We know that we're in quadrant 2 and 4. And we know that the reference angle is 41.733. So this is 180 minus 41.733, which is 138.267 degrees. And this other one is 360 minus 41.733, which is 318.267 degrees. Two more. Take a little sip here. Feeling a little parched. Solve each of the following trig equations, finding two values. So it's the same thing we just did, but we're supposed to use radians. Before we get into radians, let's quickly discuss rounded to 3 decimal places, quadrantal angles. We got 0, halfway around is pi, halfway between those fellows, pi divided by 2, and then 3 pi over 2 is this, and then 2 pi is about 6.283. All right, number 5, we have cosine of theta. We're going to come back to this here in a moment. Cosine of theta, what quadrant is this going to fall into? Well, this is equal to x, and that's less than 0. Our conclusion, theta terminates left of the y-axis. So cosine inverse, so theta is going to be cosine inverse of negative 0.9848. If you put that in your calculator, you're going to get 2.967. Excuse me. Is that between 0 and 2 pi? Sure is. So one of our answers is 2.967. Now, which quadrant is that going to fall into? Looks like it's going to fall into quadrant 2. So we know this one here is 2.967. What does that make the reference angle? Well, it's 3.141 minus that, which is 0.175. The other one we know is also left of the y-axis. It's in quadrant 3. It's got the same reference angle. So our final answer is going to be 3.141 plus 0.175, and that's going to be 3.317. Both of these answers are in radians. You do not have to have a pi to be in radians. Last one, number 6. The advice that you were given is not to use cosine or cotangent, but to use tangent instead. So tangent of theta is this little fella. This is y over x, and that's bigger than 0. Conclusion, that y and x have to be the same sign. So theta terminates in quadrant 1 or 3. Quadrant 1, they're both positive, and quadrant 3, they're both negative. Theta is going to be tangent inverse of 1 over 5.671. Put that in your calculator. I believe it's going to give us 0.175. That is one of our answers because that's between 0 and 2 pi. If we know that the answer is in quadrant 1 or 3, and we know our quadrantal angles are like so, then this is 0.175. This reference angle is also 0.175, which means this angle is 3.141 plus 0.175, which is 3.317. Once again, these are both in radians. That concludes the notes. Please do the accompanying homework, and once again, have yourself a wonderful little day there, fella.